How many movable objects are there? The pulley as well as the blocks, no? All three are movable objects. I agree that one. So let me take this as the reference. Origin, some point on the ground. So I'll define their positions here. The position of the block. Is that okay, no? So the position of the pulley XP and the position of this block can I define things like this? So I'll define all the quantities with respect to some origin. That origin is what I picked up. This one. So what is the length of the rope? These are three mobile objects. X1, their position I defined from the origin or the reference point. Anything you can take it. Now let's define the length of the rope. What is the expression for length of the rope? Should be equal to x1p minus xp. x2p minus xp. So this should be equal to x1 bar plus x2 bar minus 2 xp bar. So I'll differentiate this. So this should be v1 bar plus v2 bar minus 2 vp bar. Or further, this should be equal to 0 equal to a1 bar plus a2 bar minus 2 ap bar. So ap bar equal to a1 bar plus a2 bar by 2. A very important condition, so that is going to help us. If pulley is also in motion, then our acceleration of pulley will be related to the acceleration of block by this condition. And a1 a2 substitute with sign, you assume towards right positive. A1 a2 can be opposite, it can be anything. It all depends. In practical development we do come across situations. So if the different, if the blocks and pulleys are like that, so here I suggest you there's one diagram I introduced. So here afterwards, if you get a problem like this, these are the points on a rope. 1, 2, and this is P. So how acceleration of P will be related to acceleration of points 1 and 2 by this formula. And there's no rule that A1, A2 should be in the same direction. They can be in opposite. In numericals, you can see. So how the acceleration of this point on a rope and this point on a rope will be related to acceleration of pulley by this particular formula. Very, very important one.
Yes.
A1 and A2 will be what values? So T by M1 and T by M2, right?
No. Here don't bother anything tension, nothing. I know. So definitely what happened, I applied some force, everything. Don't bother. Just I wanted some relation between their accelerations.
Sir, is this relation independent of gravitational force, sir?
Hey, you all, why you are thinking it's kept on horizontal surface? No, don't you analyze how
Sir,
weight will
the
act?
second diagram.
So I'm just giving this idea, pa. So you must have some very good common sense, sir.
Sir, just one last doubt.
I didn't draw any blocks here. So from where you are bringing M1, M2G? These are acceleration of ropes, no?
Not that, sir. I mean, how do we find A1 bar and A2 bar?
That later on in the numerical they'll give. They're the only constraint equation I'm telling. Just analyze it. The acceleration, how the acceleration of points on a rope will be related to acceleration of pulley. That's what I didn't draw here M1, M2G, second diagram. I didn't brought M1, M2G, no? So need not to bother. How acceleration of, if the acceleration of points on a rope on either side of pulley is different, then how it will be related to acceleration of pulley. This is a constraint equation. Got it idea? Okay, now take the next one.